Good morning, ladies and gentlemen, and welcome back to physics. And we're doing our awesome field trip today to my dining room table. And Freya is outside at the moment, so it's looking like this is probably going to be like the first field trip video I've been able to shoot without her adorable snoot coming into the frame. So today we're looking at our elastic potential energy and your Hooke's law, so your spring constants, that kind of deal. So in the earlier video, I had 3 elastic bands, the blue broccoli elastic, this random beige one, which I don't know where it came from, and I think this one was from Green Onions. So these 3 different elastic bands, and they're all of varying different stiffnesses, so different spring constants, so different K value. Remembering that your units for your spring constants are newtons per meter, and that the higher the number, the stiffer the spring or that elastic band. So we're going to be testing these elastic bands to compare their spring constants. Now, I don't have a nice little force scale, spring scale, so we can actually test the amount of force we're using, but I can at least keep the force constant. So this is a mug from my cupboard, and I am going to attach these elastic bands to the mug, and then we're going to talk about the spring constants, and we're also going to talk about that one question we looked at the word suspended and what that means. Okay, so what I'm going to do is I'm going to loop these elastic bands onto the handle of the mug. Okay, so I've got these looped on there. Okay, so notice, but when there is no force of gravity in the form of the mug on the elastic band, the elastic is not stretched. However, when I let go of this, you can see how much this elastic band has stretched. Now, what I could do, and if I was organized, I would have hunted down a ruler. You know what? Let's do that. I'm going to pause this video and I'm going to get a ruler so we can actually get some data here. Now, where's my pause feature? There's my pause button. I'll be back. 2 seconds. I'm back. Okay. So I have a ruler, and with this lovely ruler, we can measure the x, or the distance that spring has extended. So we have to measure the initial distance that this elastic has before you let go of it. So you can see that. We're going to measure it using the centimeter side. So I've gone just a little bit over 2 centimeters, almost about 2 centimeters. So then when I am going to, so that's my initial unstretched distance, okay? And now we're going to get the total stretch distance here. Now let's remember, x is the amount of distortion that's distorted away from equilibrium. So equilibrium is 2 centimeters in that case. So now I'm going to measure this, and I have 11 centimeters. So that means my x value in this case is going to be a lovely value of 9 centimeters. Sorry, I got distracted for a moment. Okay, so that is what we've got there. You know, if we really wanted to determine the spring constants, I could go and get my kitchen scale. And then using the kitchen scale, we could determine what FG would be, and then we could do some math to figure out K. So if you, I'll go grab my kitchen scale, I'll give you the mass, and then you guys can figure out what K is using those numbers. I will be right back. All right, I am now back. So I've got my kitchen scale here, and I'm going to measure the mass of my mug so that we can determine FG. So we're going to turn that on, and I'm going to wait till it goes there. I don't want fluid ounces. I don't want milliliters. I don't want ounces. I want grams. So I'm going to put the mug on there. And this mug is exactly 379 grams. So 0.0379 kilograms. So you can use that number, ladies and gentlemen, in order to get your spring constant. Okay, because we have x We now have M, which once we have M, we have FG. And remember from the question that we looked at, so here's our lovely kitchen scale. Okay, so I can't really find a way to show you actually mug on it with numbers. So super handy scale. Awesome for cooking things. Come on, turn off. Off. There you go. Okay, so now this brings us to our other question of the term suspended. So let's take a moment to talk about that. Now, in the question we worked on in the lesson video, we talked about what suspended means. Now, this mug is being suspended, so it's hanging in midair. Now, remembering that because it's not moving, it's not accelerating anywhere, it means that your force of gravity, the force pulling it down, and the elastic force pulling this mug up are completely equal to each other. The vectors cancel out. So that means the force net, the F net that is acting on this mug is going to be 0. Okay, so you can use, just like we did in the lesson, the Fs is going to equal your Fg. We have Mg, we have your we've got M, we've got G. You can equate that Mg is going to equal to Kx. And then you can rearrange to find your K using the X value of 9 centimeters that I gave you earlier. So if you guys are so determined, you guys can absolutely find out the spring constant of my elastic band. This is what your lab was supposed to be. Your lab was supposed to be finding the spring constant of a bunch of cool springs. But now we're doing it with a mug. Okay, so let's compare the X value to a different mug when we're going to suspend it. Different mug, different elastic. So this guy, I'm going to loop onto my mug in the same fashion. And now this mug is a lot, this elastic is a lot softer, a lot less, well, I don't know. About the same. Well, let's find out. And we'll be able to compare X, and we'll then be able to, once we look at X, because Mg is going to be the same. The only difference is X. The only difference is going to be K and X. And then when we have a larger X value, we're going to have a smaller K value because X and K are directly proportionate to each other. Okay, so let's, when I measure this at non-equilibrium, it is 5.5 centimeters. So at non-equilibrium, at equilibrium, it is 5.5 centimeters. Well, now that it is stretched, I'm going to come back and remeasure, and it is 12 centimeters. Okay. Well, ladies and gentlemen, we find the difference. Okay. And guess what? That means our X value is actually smaller, so our K is larger. Cool, eh? Now let's look at this red elastic. Let's see if I can get around there. This red elastic's a lot smaller, right? It matches the mug better, though, with the red floral print. Yeah, I can't get the elastic around. Yeah. Sorry, guys. We can't do 3 elastics. This one's too small. So that, ladies and gentlemen, is our field trip to my dining room table. Yeah. That is for elastic potential energy and your spring constants. I think this is one of the few field trip things I haven't actually used the dynamics book for, the dynamicist book for, excuse me. Alrighty, ladies and gentlemen, I hope you guys all have a good day and no fires, injuries, or explosions.